In this example, we have a graph with 2 points, one point being 1, -1, and the other 4, 4. If we draw a line through these 2 points, the dotted line will have a particular slope. We can see that the run is 3 and the rise is 5. Therefore, putting these values into our slope formula, rise over run, we can see that this graph has a slope of 5/3. Now let's look at another example with the same coordinates. This time we will figure out the slope of a line that passes through these two coordinates, but we will use a different method. Let's refer to our uppermost coordinate as point 2 and our lower coordinates as point 1. We're going to take the value of y from point 2, that would be the 4, and subtract y1, which is -1, and place that value over x2 from the upper coordinate, and subtract the value of x1 from the lower coordinate, which happens to be 1. Now when you simplify, you see that you get a slope of 5/3, which is the same as the slope we got in the previous example. This makes sense because we were using a graph that passes through the same 2 points. This is simply a second way to calculate the slope of a line passing through 2 pairs of coordinates. Compare this method to the graph on the bottom right, and note how this method works as an alternative to using rise over run to calculate slope. In this example, we have another pair of coordinates from 2 points. We'll refer to -2, 1 as point 1, and we'll refer to the point 3, 5 as coordinate 2. Plugging the values from our new formula, we would get 5 subtract 1 over 3 subtract -2, which would give us a slope of 4/5. In this example, we have 2 more points. We'll refer to point 1 as -3, 5, and point 2 as 5, -2. We take the y value from the 2, so y2 is -2 subtract 5. We'll put this over 5 subtract -3, which simplifies to a slope of -7/8. Notice how the graph slopes downwards because this is a negative slope. In this example, we have a set of coordinates. We could take these points, graph them, and we would be able to draw a straight line that would pass through all of these coordinates. We can pick any 2 of these and just test them for slope. Let's take the first 2. Our slope will be 5 minus 3 over 2 subtract 1, giving us 2/1, which simplifies to 2. Or we could use another pair of coordinates. 9 minus 7 over 4 minus 3 also gives us 2. Or we could have picked the first pair of coordinates and the third, or the second and the fourth. Any combination would have given us the same slope of 2. This is because we can take a straight line and it would pass through all 4 of these coordinates. Our next example gives us another pair of coordinates, 6, subtract -4 over 8, subtract -10. Gives us a slope of 10 over 18. One should always reduce to simplest terms when calculating a slope. Here we have another table of values. Once again, we can pick any 2 pairs of coordinates. Often use the term points and coordinates interchangeably, so don't let that confuse you, please. -4, subtract 1 over -1, subtract -2 gives us a slope of -5. -14 subtract -9 over 1 subtract 0 once again gives us a slope of -5. And because it's a negative slope, the graph of the line passing through these points will slope down to the right.